All right, folks, I'm ready to get started. Welcome, everybody. Welcome to the end of our fourth week together. So that's it. This is a month. This is one quarter of the way. We are getting serious here. So I hope everybody is serious about what's going on here. You've been doing the homeworks. You've been reading the chapters. You've been going over the lectures, going over your notes, making sure you're getting everything as we're moving through it. Today we're going to finish off chapter 6, and then that's only going to leave 2 chapters for us to cover for the first exam. So next week we'll cover chapter 7, which has to do with the effect of taxes on markets, and then chapter 8 has to do with trade, like the benefits of trade examined through like the market model. We'll also review and use the production possibility frontier slash comparative advantage model in that chapter as well. So you'll get a slight review of that as well. So those will be the last 2 chapters we cover before the first exam. So essentially 2 weeks before the first exam. Keep that in mind. I'll mention more about that as we get closer in terms of just reminding you things that you need. But just for those of you that are interested in getting ahead, that those green skinny scantrons 8882-E are the ones we use. So if you want to get a couple of those, you'll need 3 for the semester. All right, other questions? Yeah, but I opened up the homework for chapter 6 to be due on Monday night. So it'll usually be Sunday, but maybe I'll give you an extra day like I'm doing for this chapter. Yeah. It just depends on the class. Like it depends on the performance of the class. So there's no way to know until the class takes the exam. The curve reveals itself. I always have to curve, yeah. There's nothing I can say about it now until the exam is taken and the numbers are revealed, and then the curve reveals itself. I can't say anything else about it. I'm sorry. I well, that's how you curve. You target an average, and then you have like an upper end and a lower bound for that, and then yeah. The point for every student is not to think about the curve, but to think about getting everything down so you can do the best possible. That's the best approach here. There are no curves in life. Curves will get you through classes like this sometimes if you choose to depend on them, but it's risky because you don't know how competitive the rest of the group is, so that could wind you relative to them in a bad spot. So, and beyond that, of course, in the real world, you're going up against everyone, not just people at CSUN. So you want to be the best possible that you can be at everything you do, no matter what you're doing. So don't think about the curve. Have you seen the practice exams? Okay, you haven't seen the practice exams. Make sure you look at the practice exams online. You haven't seen the practice exam, obviously. So you need to look at that. It tells you exactly the format, because those are exams that I would give in class. So just look at that. That gives you a very clear example of what the exam will be. Yeah. If that is the case, bring it up on Piazza. I'll check it. I have not had that. I've had no one tell me that in the past. So I don't know. I'll look at it. If you're right, you're cool. That's great. I'll give you the points for that. Whatever. I just have to. I have to look at it. So make sure you mention it on Piazza, and then I'll go into it. I'll look at it and see if that's the case. Somebody did mention something yesterday, and then they realized they were wrong, and then I deleted the post. So just make sure you're right about what you're talking about. So basically you're saying, is it enough for you to just study an exam that I have online and not study the rest of the material at all? No, that is not a good idea. You should be studying everything we cover in class and learning everything, and then that will help you to do well in the exam. If you just study a practice exam, that will help you to do well on the practice exam, and that is it. Other questions? All right, so I'll address more stuff about the exam as we get closer to it. But again, you shouldn't be thinking about exams. You should be thinking about the material. learning it as we move along, because again, this is a foundation for not just your understanding here, but if you're going to be in the business program, your understanding moving forward. And also, just your general understanding of like these concepts will help you kind of maneuver your way through life. The market model itself, like any market that you're dealing with, whether you're just a consumer in it or maybe you're selling in it, who knows? The basic insights you gain from like the mechanics of the model we set up here will provide you important intuition throughout your life to like, either be the best consumer you can be, or optimize your profits as a seller. So, and also moving forward in the class, like we're going to start studying the production side of things, like really get behind the supply curve for most of like the second half of the course. We'll do a little bit of the mechanics of what happens behind the demand curve initially in the second part of the course, but beyond that, it's going to be all about like studying the supply decision. And so getting this stuff now will help you get that stuff later. Everything kind of builds on each other, on itself. That's why I don't do comprehensive finals, because essentially the final is comprehensive indirectly. So that's that. So learn the stuff we're covering. Learn it. Yeah.
So is Denmark's like economy, how they have like that kind of socialist like higher tax, would they still be considered like a free market, like a capitalist market?
Yeah, definitely they are. But it's more of a mixed economy. That's sort of like the term we use to say that an economy has a greater role for government than the standard sort of like free market economy. There is no like clear-cut free market economy where the government has no role. So it's just like degrees of intervention of the government. In Denmark and other European countries that are more sort of like socialist when it comes to like public programs, they have a free market economy, obviously, but the government tends to play a bigger role, like in the case of those programs, in consumption, because they are consuming services themselves. So yeah, but they're not making decisions about what's being produced and who's getting it. So that's where the distinction lies.
So like their efficiency would be like, are they less efficient or more efficient?
Well, I mean, that's very subjective. So as far as like efficiency, as far as what we're talking about in this class, it depends on the markets, right? It depends on which markets they're intervening in, if they are setting up price controls in certain markets versus not. But oftentimes they'll just be like buyers in the market. So they won't necessarily be affecting the price. They will just be a part of the consumers in the market. And then they'll be, of course, just like transferring what they buy to the, whoever their constituents are. So that's what we call transfer payments. That's stuff you learn more about in macro, but whenever the government is giving things out to the people, it's called transfer payments. So yeah, the question is a complicated one, and simple models don't give a complete picture of it. That's why if you are interested in these issues, like go further in economics, like you can really not only gain a solid understanding of stuff, but like, maybe even like figure out ways to kind of like approach these things better. Who knows? Other questions? All right, so we are dealing with elasticity in this chapter. So again, this is more of like an extension of what we've been talking about, the market model. So just, again, going back to the beginning, start off with just establishing basic principles that underlie the logic of the approach in economics. The principles of individual choice, the principles that underlie the interaction of those individual choices, and the principles that underlie the interaction of everyone within the economy, so the economy as a whole. Those are reflective mostly of macro principles that you should learn in your macro course when you take your macro course, because you should definitely take macro, even if you are just taking these classes as GEs, because macro it provides you a lot of information about the world that you just should know as just a well-functioning, responsible citizen of the world. Beyond that, chapter 2, models, right? What are models? What do we do with models? Here's some examples of models. Make sure you know how those work. Again, we will be touching upon the comparative advantage production possibility frontier stuff once again in chapter 8 to kind of give you a refresher on some of the stuff we covered. But try to get it down now so that you have it. Then beyond that, we introduce the market model, supply demand. Then we introduce the concepts of consumer and producer surplus, which were ways of sort of gauging how well markets are doing via the market model that we use. And then in the last chapter, we talked about, well, how can we sort of use what we know, the market model and these measures of efficiency to gauge the effect of maybe government intervention in markets. So we looked at the intervention of government via price controls and quota controls and how that affects the market, how we can use the concepts that we've learned to sort of analyze the effects of those interventions. And again, that's all about sort of just gaining insights into the basic functionings of markets. They are very simple cases. They are very general cases. They don't necessarily apply to everything. So it's just a way to kind of have like a starting point, a benchmark place to kind of understand things from in order to then be able to apply analysis to more complicated real world cases. And so in this chapter, we go one more step further and we introduce this concept of elasticity, which is a measure of how responsive one variable is to a change in another variable. The ones that we're going to be interested in here are going to be the price elasticity of demand. How sensitive is demand to changes in prices? Do people respond a lot to changes in prices? Do people respond a little bit to changes in prices? And the relationship of that to the revenues that a firm can earn. There's a really strong connection between how elastic demand is and the revenues that a firm is earning, whether they're increasing or decreasing. And there's a very clear relationship that we'll establish between those two that is powerful and used quite a bit in practice. And then we'll look at a couple of other elasticities of demand. How sensitive is demand to changes in income? How sensitive is demand to changes in prices of related goods? So we'll look at these other elasticities, and then also look at, finally, at the end of this chapter, the responsiveness of supply to changes in price. So how responsive is supply to changes in price? Do they respond a lot when prices change? Do they respond a little? Let's look at the factors that affect that, and that'll be it. So that'll cover chapter 6. It's basically about you kind of understanding this concept, what it means, how to measure it, the various ones that we cover. And then, like I said, in the next chapter, we're going to look at the effect of taxes on markets. So like how does taxing a good affect the market outcome? And we're going to see that it's actually going to create similar effects to like the price controls where you wound up with deadweight loss. So we can analyze the effects of it. Also in that chapter, we'll talk about taxes in general, different taxes that exist in our economy, the different levels of taxes that you pay, be they local taxes or like federal taxes. So you'd get a little bit of practical information in that chapter about the tax system. And then finally, like I said, in chapter 8, we'll use the same model and we'll analyze the efficiency of trade. So how does trade affect the efficiency of a market? Again, it's going to be about understanding the effects on consumer and producer surplus to see who benefits and who loses from different kinds of trade policies that can be examined with this basic model. So it's all about like using this one model to kind of really understand everything that can be done with the model. And then beyond this first part of the course, we're going to start analyzing the decision making first of consumers to kind of get us an understanding of how can we have a model that it will explain the decision to consume as prices change. That winds up being very powerful, but it is a bit complicated and a bit abstract. So that's why like it's kind of like a whole separate part of the course. And then after that, we start analyzing decisions of firms to supply. And that decision is going to be different depending on whether they're operating in a competitive market, like the one we've been looking at, which is what the market model is. It's a market of a competitive market, what we call a perfectly competitive market. But also, decisions can be made in imperfectly competitive markets, which involve firms that have a lot of what's called market power, meaning that they don't have a lot of competition, sometimes no competition at all. They're monopolists. And so we have to examine that decision to supply in each of those scenarios, like each of the different market settings that a firm can operate in. And that will basically take us to the end of the course. And so beyond the 8th chapter, like we will kind of take a turn. And so that's why these first 8 chapters are like one part of the course. And then we kind of move into like other parts of the course that are more kind of thematically linked. And again, that is why we cover 8 chapters in the first part of the course. But again, like you shouldn't be overwhelmed by the idea of 8 chapters. You should kind of just understand that it's all kind of one. Aside from like chapter 1 and 2, it's all kind of one big chapter. It's all very connected. And if you kind of if you've been tracking the information as we've been building it, then it shouldn't be too hard for you to just kind of get each like branched off concept that we're covering as we're moving through these first few weeks of the course, making the first exam not as big of a challenge as people that aren't doing that generally seem to think of it as. So if you're doing what I've asked you to do well in this class, you will do well in this class. So it's all about kind of just like staying plugged in, which a lot of you are doing. I'm seeing a lot of familiar faces regularly here, which is awesome. It's really good of all of you to be making this decision to come to class because it is your first exposure to the information. But just coming to class is not enough. You should be working outside, of course. In fact, more time outside of class than in class. You have to be going over this stuff multiple times to really get it. But at the very least, you're forcing yourself to be here in front of me, use me as a resource, ask questions during the lecture. That all is like great foundational first stage for learning this material, which tends to be, for some reason, generally people just tend to think of this class as pretty challenging. But if you take the approach that I've been suggesting you take, it winds up not being that challenging. It winds up being relatively easy. So keep up the good work, folks. I want to see everybody here do really well in this class. And as you see, there's at least half of us not here. So, some of those people are on top of the stuff, but I'm going to say a good amount of them are not. So that is where I wind up having to have a curve, because people they're just not looking out for themselves. They're not making the right decisions for themselves. But you are. So good for you. Anyway, let's jump into the material now. Elasticity, again, just really quick, what we started covering last time, we covered a few of the slides, just to kind of introduce the concept. So the main one we look at is, again, the price elasticity of demand, which is the ratio of the percent change in quantity demanded to the percent change in price as we move along the demand curve. So that tells us that the price elasticity of demand is different at different points along the demand curve. But the steepness, the slope of the demand curve also carries information about elasticity. So we'll talk about that. But first, we're talking about the way to measure elasticity. So we looked at percent changes. Just in general, a percent change. So if we're talking about the percent change in quantity demanded, you look at the amount that the quantity has changed relative to the amount it was. So the change in quantity demanded divided by the initial quantity demanded times 100, because this will get you a decimal. You multiply it by 100 to get it into percent. Cent is like Latin for 100, so per 100. So this gets us into a percent change in quantity demanded if we're looking at the quantity demanded. And then you can do the same thing for price. The percent change in price is the change in the price relative to the initial price times 100. So in the figure, we see that when prices rise from $20 to $21, the quantity demanded falls from 10 to 9.9 million rides, yielding a change in quantity demanded of 0.1 million rides. So again, we calculated that to be the percent change in quantity demanded to be negative 0.1. over 10. So we started at 10, we lost 0.1, and then we multiply that by 100. Plugging that into your calculator gets us to a negative 1% change in quantity demanded. The initial price was 20. The change in price is $1. So the percent change in price equals the change in price, $1 over the initial price, 20 times 100, which gets us to 5%. And the price elasticity of demand is the ratio of the percent change in quantity demanded to the percent change in price. So if you put 1% over 5%, you get a 0.2. 0.2 is relatively low, so we say the demand is inelastic. I'll be very specific about what terms we use for what magnitudes once we finish talking about how to calculate elasticities. So let's talk about the alternative way to calculate elasticities, which is called the midpoint method, which is the way you should calculate elasticities moving forward. So the price elasticity of demand compares the percent change in quantity demanded with the percent change in price, as we already mentioned. But there's a technical issue that arises when you calculate percent changes in variables. So again, just thinking about what we were looking at here, moving from point B to point A, we're looking at a change in price of $1. But if we're going from point A to point B, we're also looking at a change in price of $1. So depending on whether we are starting from a high price and going down $1, or starting from a low price and going up $1, we're going to get a slightly different measure of the elasticity. So if we're talking about a percent change in quantity demanded due to a price increase, then you're going to have, again, going from 10 to 9.9, we're going to have a 0.1, and then you divide that by 10 as the initial starting point, multiply it by 100, and of course that gets you to 1%. But let's say you did a percent change in quantity demanded due to a price increase. So due to a price increase, we would be starting at, I'm sorry, the other case was we had a price decrease. So we started at B and went to A. So we went from 9.9 to 10 up here, sorry. And then here, it's the opposite way. It's going from 0.1. I think I wrote this up last night because it wasn't as clear last year on the slides, and so I just kind of mixed them up. This is just meant to give you intuition, so don't worry about the fact that I mixed them up. This is actually due to a price increase. This is due to a price decrease. So due to a price increase, so we're going from, no, this is due to a price decrease. I am off. I teach 3 different classes every day with 3 hours worth of different material, so just sometimes I get a little mixed up. Sorry about it. All right, anyway, so percent change in quantity demand due to a price decrease. So the price is decreasing here from 21 to 20. So we're going from this point to this point. We are, again, going from 9.9 to 1. Again, the change in quantity demanded is 0.1 again, but the starting point is 9.9 in this case instead of 10, which in this case, because the numbers are what they are, the difference in percent is not that big. It's 0.01 different, but you can get a different number if the numbers are differently, and therefore that might tell you something different about the nature of the elasticity depending on who's doing the analysis and where they're starting from. And because of that, we use what's called the midpoint method to avoid that complication. Yeah. The price decrease. So the price is decreasing. So it was higher at $21. So that's where we were, right? And then the price decreased. So then we moved along the demand curve to the 10, right? So we started at 9.9. So to avoid the complication of like us having to figure out, well, where are we starting from one point? Are we ending at a point? Like what's going to be the denominator in these calculations? We use what's called the midpoint method, which is basically to take an average of the starting and the ending point for that denominator. So the midpoint method is a technique for calculating the percent change. In this approach, we calculate changes in a variable compared with the average or midpoint of the starting and final values. The midpoint method replaces the usual definition of the percent change in a variable x with a slightly different definition. So the percent change in x is going to equal the change in x as a fraction of the average value of x. times 100, where the average values of x is defined as the start value of x plus the final value of x divided by 2. So you add those two together and divide by 2 to get that average value of x. When calculating the price elasticity of demand using the midpoint method, both the percent change in the price and the percent change in the quantity demanded are found using the midpoint method. So again, if I ask you to calculate elasticity at all in this class, or you are asked to calculate elasticity in an economics course, you are expected to use the midpoint method. All right, so to see how the method works, suppose you have the following data for some good. So at a price of 0.9, quantity demanded is 1,100. If the price were to go up by 20 cents, quantity demanded goes down to 900. So to calculate the percent change in quantity going from situation A to situation B, we compare the change in quantity demanded, in this case a fall in 200 units, with the average of the quantity demanded in the two situations. So the percent change in the quantity demanded is equal to, in this case, negative 200. So remember, sometimes we're going to have, when I'm talking about the price elasticity of demand, we're always talking about a number that's going to be negative. And so I've left it out sometimes a negative. It doesn't matter as long as you understand that for the price elasticity of demand, no matter what, it's always going to be negative. You don't need to see it. It's just, because that's the nature of the measure. For the other elasticities, whether it's positive or negative will matter, and so we'll talk about that when we get to them. But as far as the price elasticity of demand, whether you add the negative there or not, it doesn't matter. What matters is your final calculation. So here we've got a change in quantity demanded of 200 over the average of the starting and ending points. You have 900 plus 1,100, which is equal to 2,000 divided by 2 times 100. So then you've got negative 200 over 2,000 divided by 2, which is 1,000. So that's the average of our starting and ending point. So then you have the drop in quantity demanded as a fraction of the average of the two, the starting and the ending point, which is 1,000, which then equals 0.2 times 100, which equals 20%. So the percent change in quantity demanded using our midpoint method, in this case, is equal to 20%. In the same way, we calculate the percent change in price. So the percent change in price, again, we're looking at a drop of, here's an increase of 20 cents. And that's going to be as a fraction of the average of these two. So 90 cents plus $1.10 divided by 2. $2 divided by 2, so the average is $1. And that's going to be times 100. So you have 20 cents divided by $1 times 100, which winds up equaling 20%. So in this case, we would calculate the price elasticity of demand to be the ratio of the percent change in quantity demanded, calculated using the midpoint method, to the percent change in price, calculated using the midpoint method. So that's going to be equal to 20% divided by 20%, which is $1. Sorry, I'm 1. It's 1. It's equal to 1. And I dropped the negative sign again because it's implicit in the measure that it is a negative number because of the law of demand. As quantity goes up, price goes down. So that's essentially what we're deriving this measure from that law. So it's always going to be negative even if we show it or not. What's important is being able to measure the percent changes properly using the midpoint method. So make sure you can do that. We'll look at another example right now. Are there any questions about how I did this one though? Yeah. Yeah. So remember, you will be able to use calculators on the exam. Yeah, you can do that, but yeah, this is the absolute value of the measure, yeah. So to arrive at a more general formula for price elasticity of demand, suppose that we have two data points on the demand curve. Let's say one data point tells us that at some quantity Q1, the price is P1, and at some quantity Q2, the price is P2. So these subscripts denote values that are different from each other, even though we're using the same symbol to represent price. The subscripts differentiate them from each other. Then the formula for calculating the price elasticity of demand is, of course, going to be this formula here, the ratio of the percent change in quantity demanded over the percent change in price. These would each be multiplied by 100, but then you'd have 100 over 100, which cancel out, so they drop out. So then you're just left with this ratio here. Again, the difference between the quantities divided, which is the drop or increase in quantity demanded, depending on whether we're talking about an increase or a decrease in price, divided by the average of the two. And then again, the difference between the prices, either an increase or decrease, divided by the average of the prices, and that'll get us the price elasticity of demand. So this is just a general specification of the formula we just used to calculate the elasticity of demand using the midpoint method. As before, when finding a price elasticity of demand calculated by the midpoint method, we drop the minus sign and use the absolute value. Absolute value, again, for those of you that are a little shaky on it, is just the distance of any number from 0 on the number line. So if you have a -1, the absolute value is 1 unit from 0, so it's 1. Another just quick example from the homework. The price of notebooks is $5, and at that price, consumers demand 12 notebooks. If the price rises to $7, consumers will decrease their consumption to 4 notebooks. So using the midpoint formula, what is the price elasticity of demand for notebooks? So let's just go through the computation one more time. So again, what is going to be the change in quantity here? What is the average of the quantities? Of the quantities. The starting and the ending point are what? 8 is the average, right? Yeah, starting point is 12, ending point is 4, right? Add those together, you get 16 divided by 2, which is 8, right? What about, how much is the change in price here? And what is the average of the prices? 6, right? 5 plus 7 is 12, divided by 2 is 6. Okay. So now just plugging all this into our formula here. So it doesn't matter which one you use as far as like, if we're talking about here like the price going up and therefore the quantity demanded going down, I just put the bigger number first just to avoid the negative altogether. So just to avoid the complication of negative, I usually just put the bigger number first to get a non-negative number on both the numerator and the denominator, just to avoid that whole complication, because again, it is implied that the price elasticity of demand is always negative. So you have 12 minus 4 divided by the average of those two. So 12 minus 4 divided by the average of 12 plus 4 is 16 divided by 2. So you have 8 divided by 16 divided by 2, which is equal to 8 divided by 8, which is equal to 1. And then in the bottom, we've got the difference in prices. I just put the bigger number first, 7 minus 5 divided by the average of the two. 7 plus 5 is 12, divided by 2 is 6. So you've got 2 divided by 12 divided by 2, which is 2 divided by 6, which is equal to 1/3. So 1 divided by 1/3 is equal to 3. So if you have a ratio of 2, if you have a ratio of 2 ratios, which this is 1 over 1 divided by 1 over 3, that's equivalent to the top ratio times the reciprocal of the bottom ratio, if you remember that from your properties of ratios. But whatever, you can just plug this into your calculator if you don't, if you're not able to manipulate this on your own, and just figure it out that the price elasticity of demand here is 3. So demand is elastic. Question? There wasn't a hand? I thought I saw a hand. Anyway, so there you go. Make sure you can calculate the price elasticity of demand using the midpoint method. Yeah, any kind of math that you encounter either in this class or other classes, like if you're like, first of all, and this is important, like if you think that you're the kind of person that's quote unquote not good at math, that doesn't mean that you are inherently bad at math. It means that you just haven't done enough math before, and that means you need to sit down and do a bunch of math. Just do more and more and more math until you really get it, until it just starts clicking, and then you've got it, you got the math. This whole notion of people being inherently good at math and others not being is absurd. People that are really good at math are really good at math because they've been doing a lot of math throughout their lives. And it's likely because they really had They had really strict parents that just like cracked the whip. You better do that math homework, kid, every night until they got the math down. I was one of those kids. Like, I was afraid of my father. I would do my homework endlessly, and I got really good at math really early on. And then that carried me through all my math courses, through even after I decided to become a film student and get the degree and all this stuff, and decide, no, I want to become an economist. Oh, we have to do a lot of math. I just went back, learned all the math again like that, and then just got right back on that horse, took that understanding further, learned even more complicated math, and then now I'm able to just use math at will. So don't let the idea that you're bad at math get in the way of you dedicating yourself to doing a lot of math so you can get better at it. Those of you that are going to go into the business program, you're going to be expected to take business calculus, and you're going to be expected to be able to do that stuff in the upper division business courses. Like, you cannot let yourself get in the way of you just like becoming good at math. And if you carry with you this belief that you are inherently bad at math, then you will stop yourself from getting good at math, and you will not do good at math, and you will be bad at all your business courses, and you will fail, and you will have to drop out of the business school. So it's true. I have upper division people right now, people that just like skated by the Math 103 course, which is a business calculus course. And all my upper division courses, you have to use some calculus in all this stuff, but like at a higher level, and just the performance is atrocious generally, and it's really just people just getting in the way of themselves, and it's really unfortunate. Really unfortunate. Don't let that happen to you. Just like work really hard always on improving things that you think you're not good at. There's only one way to get better at anything, and that is to devote as much time as it takes to get better at it. That is it. Everything that you want to accomplish requires time. End of story. Yeah.
So I remember in the mathematics that when we did the elasticity price, it was like there was a graphic, like people don't want it, it was less than one, and it was.
We're gonna cover that right now.
Okay, so when you have the number 3, and you say that means the last, like how does that translate?
I'm gonna tell you that right now. We're about to get to that. Yeah, I haven't gone to that definition yet, but yeah, okay. But I appreciate that you know that. I want to get ahead. That's good. Yeah, I know. I was gonna expand on it. All right, but I did mention last time that if it's small, we say inelastic. If it's large, we say elastic. But now I will get very specific about what I mean by that with the numbers. Interpreting the price elasticity of demand. All right, so how elastic is elastic? So first, consider the demand for a good where people pay no attention to price, meaning that they will buy the good regardless of the price they have to pay for it. So life-saving medicine is an example. You know, like if you need that medicine to save your life, you are going to pay whatever it takes to get that. Sometimes we see companies taking advantage of that. Recently, there was this whole thing going on with like this EpiPen or something. It's like this emergency shot that people give themselves that are allergic to peanuts. Like, you know, there's some of these people that are allergic to peanuts. If they eat a peanut, they could die. Like, they just start gagging, can't breathe, and they can die. They carry these EpiPens with them just in case, you know, maybe some peanuts were slipped into like some ingredient in something they're eating, and they need to save their lives. And the company recently took a huge advantage of this fact and like upped their price by like, I think it was like 1,200%. So like 12 times the price was raised. There was a big backlash, and generally like you will get a big backlash like that, and sometimes it will be effective, sometimes it won't, and sometimes companies will be able to get away with it. But nonetheless, like regardless of whether or not the company was affected by the influence of the public outrage, you know, whoever needed that pen was going to pay for it no matter what, right? Like, you need to save your life, like, so you will pay for it. So the demand for that type of product is very inelastic. In fact, we say it is perfectly inelastic. So suppose the consumers, in this case, we're talking about snake venom. So here's the price of snake venom per dose. Here's the quantity of snake it's anti-venom. It's anti-venom. Quantity of snake anti-venom, thousands of doses. So quantity, price, standard, market, coordinate plane. So here again, like, you know, if somebody gets bitten by let's say a rattlesnake or something, some kind of poisonous snake, they're going to need that anti-venom to save their life. So they are not going to care about the price. So suppose the consumers will buy 1,000 doses of anti-venom per year regardless of the price. So let's say there's an increase in price from $2 to $3, the quantity demanded will not change. And therefore, you will get a vertical demand line. Like the demand will be perfectly inelastic. There will be zero response to changes in price, which will be reflected in the fact that the curve is a horizontal line. So that again, this will leave the quantity demanded unchanged. Since the percent change in quantity demanded is zero here, so you have a change in price, but the percent change in quantity demanded is going to be zero. The price elasticity of demand, in this case, will be zero. So again, remember, price elasticity of demand, ratio of percent change in quantity demanded to percent change in price. So if the percent change in quantity demanded is zero, you've got a zero as the numerator, which means the whole number is going to be zero, which means our price elasticity of demand is going to be equal to zero. And therefore, you will have perfectly inelastic demand when the quantity demanded does not respond at all to changes in the price. When demand is perfectly inelastic, the demand curve is a vertical line. So that's the extreme end of how elastic demand can get. And obviously, there's got to be another extreme end where demand will be perfectly elastic, as sensitive as possible to changes in price. And so the opposite extreme occurs when even a tiny rise in the price will cause the quantity demanded to drop to zero, or even a tiny fall in the price will cause the quantity demanded to get extremely large. When you have a situation like that, you're going to have a flat horizontal demand curve, again representing the fact that the price elasticity of demand is perfectly elastic, as sensitive as possible to price changes. So just imagine any market for like the most generic good, like cotton balls, like whatever. Everybody can make cotton balls. Nobody can make like their special version of cotton balls, which is better than my competitor. So if I raise the price, you would buy mine. No. We just buy cotton balls, the cheapest ones. That's what we do as consumers when things are very general, very generic, and there's like 1,000 options. We're going to buy the cheapest one. We're not going to care about the brand because whatever. It's the same thing no matter who's selling it. Under those circumstances, you have perfectly elastic demand. If the seller were to try to raise their price by even $1, even a penny, then quantity demanded would go down to zero in the most extreme case. And if the price were to go down by even a penny, quantity demanded would become infinite because, again, your price is now slightly lower than everybody else's. So roughly speaking, so in this case, the percent change in price would be zero. So you'd have some percent change in the quantity demanded, but the percent change in price would be zero. And so what essentially you have for our price elasticity of demand relationship, you would have a zero in the denominator, which is not possible mathematically. So whenever you have zero in the denominator, you wind up getting an infinite result. So we say that the price elasticity of demand is infinite under this very extreme circumstance where the quantity demanded is as sensitive as it possibly can be to changes in price. And therefore, we say demand is perfectly elastic. When any price increase will cause the quantity demanded to drop to zero, the demand is perfectly elastic, and the demand curve is a horizontal line. So this actually will wind up being very relevant when we start talking about decisions of firms to produce in perfectly competitive markets. They will face a perfectly elastic demand curve, and that will have an effect on what they can charge, how much they're going to supply, and their overall profits. So we'll talk all about that when we get to that part of the course. But just know that, like, we don't just cover things randomly in this class. It's all kind of connected, and these cases do matter. So again, the more elastic demand is, if it's perfectly elastic, it's going to be horizontal, the demand curve. If it's perfectly inelastic, not sensitive at all to price changes, the demand curve will be a vertical line. One sort of mnemonic way of remembering that is like the perfectly inelastic demand is a vertical line, which is kind of like an I, which is like the first letter of inelastic. So you can kind of organize the information in your head that way. All right, so the price elasticity of demand for the vast majority of goods is somewhere between the two extreme cases, right? We're always going to have that downward sloping demand curve generally. So economists use one main criterion for classifying the intermediate cases, the cases in between perfectly inelastic and perfectly elastic demand. So we ask whether the price elasticity of demand is greater than or less than equal to 1. We say that demand is inelastic if the price elasticity of demand is less than 1. And so the steeper the demand curve, the more inelastic demand we'll get as it approaches like the perfectly vertical line. So if it's close to that or just very steep, then you know that the demand overall will be inelastic. So in this case, at $40, folks demanded 80 units. If the price goes up to $50 in this case, the quantity demanded goes down by 5 units. So the rise in price causes a small decrease in quantity demanded if demand is inelastic. If the price elasticity of demand is greater than 1, then we say that we have elastic demand. And elastic demand, remember, the most elastic demand can be is perfectly elastic, which is a horizontal line. And so the flatter the demand curve is, the more elastic demand is in that market. So in this case, if we were at this initial point here, where $40 corresponds to 80 units demanded, the same increase in price would result in, so if the price were to go here to $50, then the quantity demanded would decrease quite a bit in that case, from 80 to 20 units. So we see that demand is very elastic, and again, that is captured by the fact that the slope is pretty flat, almost heading to that like perfectly elastic flat demand curve. So remember, the slope of the line, how steep it is, will tell us something about how elastic demand is in a market. And of course, if the price elasticity of demand is exactly equal to 1, we say that we have unit elastic demand. This will play a big role when we talk about the relationship between elasticity and revenues that a firm can earn. Yeah. Yeah. Yeah, the rise in price, right. The same price increase. I guess this is the first part up here, yeah. Yeah, sorry about that. The point is to make sure you understand that if the price elasticity of demand is less than 1, we say price elasticity is inelastic. If it's equal to 1, we say it's unit elastic. And if it's less than 1 in absolute value, we say that it is inelastic. And of course, the relationship between the steepness of the curve and the elasticity. All right, to see why a price elasticity of demand equal to 1 is a useful dividing line, let's consider a hypothetical example, a toll bridge operated by the State Highway Patrol Department, right? There's a toll bridge. People want to get from one part of town to another. They have to pay the toll, whatever. There's a price. That price can vary depending on what the needs of the municipality are. So here's our price. Here's our quantity demanded. Here's a demand curve. Initially, we're at point A, where the toll is 90 cents. That corresponds to 1,100 crossings per day. And if the price goes up to $1.10, that corresponds to 900 crossings per day. So that's a 20% increase in price and a 20% decrease in the quantity of crossings. So again, if you were to plug in our information into our midpoint formula for calculating the elasticity, then we would wind up, in this case, with 1. So we have unit elastic demand here. All right, so the figure shows a case of inelastic demand for the same situation when you've got a toll being raised from 90 cents to $1. So inelastic demand, you're going to imagine that the percent change in quantity demand is going to be less than 20% in this case. The percent change in price is the same, 20%. So the same 20% rise reduces the quantity demanded from 1050 to 950 in this case, which is a 10% decrease in the quantity of crossings. So again, we've got the same formula. I've gone through this a few times already. That's why I'm just clicking through the math. Make sure you go home and practice it if you want some more practice. But in this case, we see that the price elasticity of demand is equal to 0.5. So it's less than 1 in absolute value. So it is price inelastic, we say. Yeah. It would be like a 1-to-1. It would have a slope of 1, essentially. It'd be like a 1-to-1 relationship, yeah. It's just the cutoff point, but we're about to highlight why that's an important point right now, yeah. So anyway, so here we've got a more inelastic demand, and we see that if we calculate it, we have a 0.5 elasticity of demand, which means that demand is inelastic because it's less than 1 in absolute value. The final figure shows a case of elastic demand when the toll is raised from 90 cents to $1.10. So this, again, represents a market where people are very sensitive to changes in price. So you see that the demand curve is flatter than the prior two cases. So in this case, a 20% rise in price leads to 400 less crossings per day, which winds up being a 40% decrease in the quantity of crossings. So the percent change in quantity demanded is greater than the percent change in price. So you're going to get a number bigger than 1. So we're going to have elastic demand, just numerically speaking. So again, plugging in our information here, we wind up with a 2 for our price elasticity of demand. Again, the number is bigger than 1, and therefore we say demand is elastic just based on what the number is telling us. So why does it matter? Why does it matter whether demand is unilastic, inelastic, or elastic? So again, because this classification predicts how changes in the price of a good will affect the total revenue earned by producers from the sale of that good. Total revenue is equal to the total value of sales of a good or service. It's equal to the price of something multiplied by the quantity sold, right? Price times quantity equals revenue. So again, total revenue equals price times quantity. So total revenue has a useful graphical representation that can help us understand why knowing the price elasticity of demand is crucial when we ask whether a rise in price will increase or reduce total revenues. So the figure shows the elastic demand curve for tolls. So it shows the last case we were looking at, where we had that price elasticity of demand to equal 2, which meant that price was elastic. So at this point right here, where 90 cents corresponded to 1,100 units demanded of toll crossings, the rectangle made up of the price times the quantity is a graphical representation of the revenues. It's a graphical representation of the price, which is the amount on the vertical axis, times the quantity, which is the amount on the horizontal axis. So that's how you can identify revenue graphically, just looking at the price and the quantity, and just basically getting the area of the rectangle that is made up by those combinations. So again, we're looking at elastic demand for the toll. In general, the total revenue at any given price is, again, equal to the area of the rectangle, whose height is the price and whose width is the quantity demanded of that price. So to get an idea of why total revenue is important, consider the following scenario. Suppose the toll on the bridge is currently 90 cents, but that the highway department must raise extra money to repair their road. So they're trying to figure out, should we raise our price or should we lower our price? So one way to do this is to raise the toll on the bridge. So again, we're talking about elastic demand here. People are very sensitive to changes in price. So if the traffic on the bridge drops a lot, a higher toll would actually reduce total revenue instead of increasing it, because people are very sensitive to changes in price. You raise the price, you're going to get a lot of people saying, you know what, I'll find an alternate way to get to town or whatever. Like, I'm not going to pay the toll. So they're going to lose revenues from people that are no longer buying, even though they'll increase revenues from the increased price they're going to charge to those who are still willing to buy. So in the figure, we'll see graphically how the toll increase affects total bridge revenue. So again, we've got at 90 cents, we've got this entire area which represents the total revenue, which is made up of both of these areas A and B because they're going to be chopped up in a second. So again, that's just the revenue we were looking at, 90 cents times 1100. After the price is raised to $1.10, so again, we're over here, the price is raised to $1.10, total revenue is now given by the sum of the areas C and B, right? The price $1.10 times the quantity demanded at $1.10, which is 900. So when the toll is raised, revenue is going to increase. Revenue represented by area A will be lost. So you're going to lose this amount of revenue, right? These were the 200 people that are no longer willing to buy at the higher price times the 90 cents they were paying. So that revenue is gone. And then in this case, the city is going to earn extra revenue from those people that are still willing to buy and are now willing to pay an extra 20 cents per toll. So there's going to be 900 people times 20 cents. So area C represents the increase in revenue from the increase in the price. All right. So the 900 who continue to use the bridge contribute an additional, in this case, 20 cents times 900. So they contribute an additional $180 per day to total revenue. But the 200 drivers no longer using the bridge generate a loss of total revenue of that 90 cents times the 200, which is $180 per day. So except in the rare case of a good with perfectly elastic or perfectly inelastic demand, when a seller raises the price of a good, you're going to have these two countervailing effects present. One of them we call the price effect. So the price effect, after a price increase, each unit sold sells at a higher unit, which tends to raise revenue. So you're going to have that price effect from those people that are still willing to buy the higher price. And so in this case, area C represents the price effect of this price increase for the toll crossing. And then you're going to have the quantity effect, which is going to offset the price effect, which again is represented by this area A. After a price increase, fewer units are sold, which tend to lower revenue. So except when you have those extreme cases where you have that perfectly inelastic demand, vertical demand, or perfectly elastic demand, horizontal demand, you will always have these countervailing effects, price effect and quantity effect, of changes in price, which are either going to result in an increase or a decrease in total revenue for a firm. And in this case, since we're talking about the city is the firm. They're producing toll crossings. All right, so in general, the effect on total revenue can go either way. A price rise may either increase or decrease the total revenue, and it's going to depend on the elasticity of demand. If the price effect, which tends to raise total revenue, is stronger of the two, then total revenues will go up. If the quantity effect, which tends to reduce total revenue, is stronger, then total revenue will go down. And if the strengths of the two effects are exactly equal, then total revenue will be unchanged. Yeah. So we're just looking below the demand curve here, right? So because we don't have the supply curve here, like we can't really do that kind of analysis. Yeah. So just stick with no, that's cool. That's good that you're trying to bring it all together. But this is merely meant to highlight the connection between elasticity and revenue. So just kind of keep going with the logic here. So the price elasticity of demand tends to tell us what happens to total revenue when price changes. Its size determines which effect, price or quantity, is stronger. So there's two ways to look at it. You can look at it from the perspective of a price increase or the perspective of a price decrease. So let's look at it from the perspective of a price increase first. Let's say the toll is 90 cents and it's going to $1.10. So the toll is going up. If the demand is unit elastic, then we see that the total revenues will remain unchanged, that the quantity effect and the price effect will exactly balance each other out, and total revenues will remain unchanged if the price elasticity of demand is unit elastic. So regardless of whether we're looking at it from a price increase or a price decrease, that effect is the same. If we're looking at it from a price increase and we're looking at inelastic demand, so if demand is inelastic, if we are raising our price, therefore lowering the quantity demanded, then in that case, the total revenue is going to go from, in this case, $945 to $1,045, which means that in this case, the price effect will outweigh the quantity effect, and therefore the revenues will increase when demand is inelastic and we are raising prices. But if we are decreasing prices, so if we're going from $1.10 to 90, which means that quantity demanded will increase, then in this case, the revenues will actually go down in the opposite direction. So in the opposite direction, when you are lowering the price, the total revenues will go down because you're lowering your price, you're increasing quantity of people, but the drop in the price effect will outweigh the quantity effect, and that will decrease total revenue. Yeah. That was unit elastic, right? Because it was exactly equal, right? Exactly. All right, and then finally, if demand is elastic, if we're looking at it as a price increase, so if we have total revenues of 1080 initially, and then you increase the price, we see that total revenues go down, and that's because people are very sensitive to changes in price. So as the price goes up, the quantity effect will outweigh the price effect, and total revenues will decrease. But the other way around, if you think about it as like $1.10 going down to 90, then in that case, the price effect will, in this case, the quantity effect will outweigh the price effect again, but in the opposite direction, which will actually increase total revenue. We'll look at this again graphically right now to kind of solidify and summarize all this information. So let's talk about the price elasticity along the demand curve. So again, we've been talking about the price elasticity with respect to the steepness of the curve, but along the demand curve, the price elasticity also changes. So demand in a market can be overall elastic, inelastic, unit elastic, depending on the steepness of the curve, but also along the curve that will also be changing. So when the price is low, so let's say we're talking about a low price here, maybe like 1 to 5, raising the price will increase total revenue. So here's our downward sloping demand curve, and here is our total revenue curve. Total revenue is on the y-axis, quantity is on the x-axis. So this quantity corresponds to this quantity here. So over this range over here where price is low, when price is low, demand tends to be inelastic. Over that range, let's say we're starting at a price of $1, which corresponds to quantity demanded of 9 units, and the firm wanted to raise their price. So to raise their price, people are going to buy less. So by doing that, we're going to move up along demand curve to a higher price. So down here we see that over the inelastic range of demand, if the firm raises their price, they're actually going to increase revenues. And in that case, the reason for it is because in this case they're raising the price, so that means the price effect is going to outweigh the quantity effect. When the price is high, and let's say it tries to raise the price over that range, then that will actually reduce total revenue. So if we're talking about this range over here, the high price range of demand, you're going to have elastic demand. And over the elastic range of demand, as the firm tries to raise their price, so let's say they're right here at like $6 corresponding to 4 units demanded, and they want to raise their price, let's say to $8. To do that, the quantity demanded drops down to 1. When that happens, we see that total revenues will decrease along that range because demand is elastic. And what that basically means is that the quantity effect, the quantity effect will, so the price effect will not be that large, and the quantity effect, the amount of people that are no longer buying will outweigh it, which means that total revenues will decrease. Yeah. So that's a completely different concept. That's actually more of firms that use the consumer surplus to sort of gauge like how much can they charge for like packaged versions of their product rather than individual units. So what they'll do is they'll measure the consumer surplus, and then they'll figure out how much is that valued in the market, and then they'll add that price to like a packaged version of the good. Yeah. This is more just about understanding like the overall elasticity that a firm is operating in their market. Like, let's say I'm a computer manufacturer and I'm charging a certain price for my computers, and I'm trying to figure out what should I do right now? Should I raise my price or lower my price in order to increase my revenues? Well, it's going to depend on how elastic my demand is. If my demand is inelastic, that means if I raise my price, my revenues will go up. But if my demand is elastic, then if I raise my price, then my revenues will go down. And so that's what that's for. And then we see that at the point, so again, this is a very simplified version of everything that exists in the world, and therefore we are dealing with a linear demand curve, which is what allows us to clearly establish this relationship. It becomes a little bit more complicated when the demand curve is a little bit curved. But in the case of a linear demand curve, when you have a elasticity that is unit elastic, then that's going to correspond to the point where total revenues are at their maximum. So that's one way for a firm to identify how they can maximize their revenues, the amount they're selling, the benefit they get from selling, which is the price times quantity. They just identify the point, the price at which their demand is unit elastic, and then they kind of target that in order to maximize their total revenues. So the relationship between elasticity and revenues is super important and often used throughout business. So not just some silly concept in economics courses. All right, what factors determine that? What time did we start? Are we done at 1:45? Okay, all right. What factors determine the price elasticity of demand? In general, there's four main factors that determine the price elasticity of demand. The first is whether a good is a necessity or luxury, right? If a good is a luxury, then it's going to be very elastic. The demand is going to be very sensitive to changes because, again, like these things aren't necessary. So if prices change too much, people will jump ship. Versus if it's something that's a necessity, we saw that like with life-saving stuff, demand was perfectly inelastic. So if something's a necessity, you're going to have more inelastic demand versus something like a luxury that's not necessary, which will be more elastic. The availability of close substitutes. How are there things that I can substitute for the thing that I want to buy? For that life-saving pen, no. They have a patent on it. I can't buy a generic version. Nobody else is selling it. So because of that, price is very inelastic. In fact, it's perfectly inelastic. But like aspirin, there's 1,000 versions of aspirin. If one person tries to raise their price, I'm going to buy aspirin from somebody else. So demand is going to be perfectly elastic for that case. So again, the availability of close substitutes will affect the elasticity of demand. The share of income spent on a good. How much of your income is going to the thing you're buying? If it's just salt, whatever, it's like $1, not even $1. If it changes to $2, you're going to buy the same amount of salt. You like salt in your food, you're going to buy it. Price doubled, whatever. It's going to be very price inelastic because it doesn't make up a large portion of your income. Versus your rent, right? For your home, your mortgage, whatever you're paying for your housing, that doubles, you're jumping ship immediately. That's a huge part of your income. That doubles, like it's basically taking away your ability to buy a bunch of other stuff. Like you just can't handle that. You will immediately respond to that. So it will be more elastic, your response to that, because of the fact that the good that you're buying is a big part of your income versus a small part like salt. And then finally, time elapsed between price changes. So how much time do you have to find alternatives? If a price changes immediately, you may not have enough time to like find substitutes for it. So price will be less elastic in the short run, however that long that is, versus the long run when people have more time to seek out alternatives. So as time increases, demand becomes more price elastic. All right, other elasticities of demand. So there's the cross-price elasticity of demand, which is essentially a measure of how sensitive the quantity demanded is of one good to price changes in a related good. Remember, there's two types of related goods, substitutes and complements. Substitutes, if the price of one good goes up, people substitute away from it to substitutes. Like if the price of Coke goes up, people buy Pepsi. Those are substitutes. versus complements. If the price of one thing goes up, like peanut butter, people buy less peanut butter, but they also buy less jelly. Those are complements, right? As the price goes up, the quantity demanded goes down for both of them. So the question is, how sensitive is price? How sensitive is quantity demanded to changes in the price of related good? And we can measure that with the cross-price elasticity of demand. Between two goods measures the effect of a change in one good's price on the quantity demanded of the other good. It's equal to the percent change in the quantity demanded of one good divided by the percent change in the other good's price. So it's basically exactly what we've been doing, but just in the denominator here, we're looking at the percent change in the price of the related good. When two goods are substitutes, like hamburgers and hot dogs, the cross-price elasticity of demand is going to be positive because, again, as the percent change in the price of hamburgers goes up, the quantity demanded of hot dogs will go up. So these will both move in the same direction, and so you have a positive over a positive, so the cross-price elasticity of demand will be positive, versus if they're substitutes. Versus if they're complements, right? If they're complements, the price change of one will lead to a quantity demanded decrease in the other. So if you raise the price of peanut butter, people will buy less jelly. So the cross-price elasticity of demand for complements will be negative, and therefore the sign, whether it's positive or negative, of the cross-price elasticity of demand matters. And then how big the number is tells us how closely related the goods are. All right. Income elasticity of demand. The percent change in the quantity of demanded when a consumer's income changes divided by the percent change in the consumer's income. So this allows us to determine whether a good is an inferior or a normal good. Remember, a normal good, if incomes go up, you buy more of it. If it's an inferior good, incomes go up, you buy less of it, right? Like frozen foods. You buy less frozen foods as you get a job and get more money. So that's an inferior good generally. So the income elasticity of demand will tell us whether the goods are related as normal or inferior. So let's say income goes up by a certain percentage and then quantity demanded goes down. That means the good is what? Income goes up, quantity demand goes down? Inferior good. So if we have a negative income elasticity of demand, we know the goods are related as inferior. The good is considered an inferior good within the market. When the income elasticity of demand is positive, the good is a normal good, right? If the percent change in income leads to a positive percent change in quantity demanded, then those are both going to move in the same direction. So you're going to have a positive value for income elasticity of demand. So again, the sign will matter for the income elasticity of demand, and it will tell us whether the goods are normal or inferior. This is information you can get from statistical analysis of markets. All right, and finally, let's talk about the price elasticity of demand. Give me 2 more minutes, please, if you don't mind. I might go over by a minute. So the price elasticity of demand is a measure of the responsiveness, how responsive the quantity supplied of a good is to the change in the price. It's the ratio of the percent change in the quantity supplied to the percent change in the price as we move along the supply curve. So again, you measure it as the percent change in quantity supplied over the percent change in price. And you could have 2 extreme examples where you have perfectly inelastic supply, right? Suppliers are not responsive at all to changes in price. In this case, we're talking about cell phone frequencies, which are supplied by the government. There's only a fixed amount of cell phone frequencies, so they just supply that amount. So supply is perfectly inelastic. So that's perfectly inelastic supply. If the price elasticity of supply is 0, changes in the price of the good have no effect on the quantity supplied. Versus the opposite extreme, where you have perfectly elastic supply. So in this case, price of pizza. In this case, there's a lot of people that could supply pizza an infinite amount, in fact, because it's really easy to make pizza. And so the responsiveness of quantity supplied is very sensitive to changes in price, as sensitive as possible. If the price goes up a little bit, you get a bunch more manufacturers in there. If it goes down by even $1, everybody jumps ship because their costs won't be met. So you have perfectly elastic supply there. And then finally, the 2 things that affect the price elasticity of supply is the availability of inputs. If it's really easy to buy the stuff you need to produce, then you're going to have really elastic supply versus something where like maybe you own the patent to an input into your production that nobody else can produce. Then supply will be very inelastic in that case. And then finally, time, right? Initially, as prices change, supply will be relatively inelastic to the long term because it takes time for other companies to come in and set up shop, or maybe existing companies to exit the market. So these are the two main forces that will affect the elasticity of supply. All right, folks, so just basically know all the measures. Definitely know how to measure price elasticity of supply. I won't ask you to measure the other ones, but just understand what they are. Understand for cross price elasticity and income elasticity what the signs mean, and just understand supply and the price elasticity of supply and what affects it. Have a great weekend, folks. I will see you on Tuesday. I think is it a long weekend? It's not. Oh, that's next weekend, right? Oh, anyway, just have a good weekend. Enjoy your weekend.